Hello, Algebraites. One of the key things that we're going to do, and we've already classified polynomials, is that we're going to graph polynomial functions and describe their end behavior. Now, actually, we're just going to graph by using a calculator this time, but mostly we're going to be predicting a graph and describing the end behavior. So, let's go to the next page to figure that out. So here we are on page 2. Turning points and end behavior of polynomial functions. So, a turning point. Well, a turning point is exactly what you think it is. A turning point is a change in behavior. So here we have this graph of the function, and notice it's a quartic function to the power of 4. And it starts from high, so it's coming down, 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 down. Then it hits this point right here where it starts to go up. So its behavior now changes. Down, 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 now it's up. And then this one keeps going until it hits this high point, and then its behavior changes. Now it's going downward, hits a low, and upward again. So let's take a gander at turning points. First off, each of these right here is a turning point. This is a turning point. Each of these is a turning point. So there's 3 of them. And we just list them as a point, right? So the turning point itself is negative 2.236, comma, negative 16. Another one is 0, 9. And the last one is 2.236 and negative 16. There we go. Now, end behavior. Let's explain what end behavior is. Notice that this W-shaped graph actually goes on forever in this direction and goes on forever in this direction. So what are its ends doing? Well, this one starts up and ends up. So the end behavior here is up, 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 up. Because there's 2 ends, the left end and the right end. And this one starts in the up, from the up, and goes to the up, like so. Let's quickly notice the differences in the other one here. So let's come and see number 1 here. Number 1 starts low and ends high. So its end behavior from left to right is down, up. Down, up. Okay? Now notice number 2 here. Number 2 here starts down, ends down. Down and down. That's its end behavior. So from the left, down, and then ends down there. And the same thing here with 3, we can analyze what that is here. Up, down. So that one's up and down. Now our key on this one is that we want to be able to consider the pattern here. Consider the pattern. And I want you to pause the video in just a moment, but consider this here. Notice that this is up, up behavior. And what do we notice about this whole term? This is a down-up behavior. What do you notice about this whole term? The highest exponent. Same thing here. Down-down. What do we notice about this highest exponent term? And lastly, up-down here, and this one here. So pause the video, contemplate that, and see if you can work through that down here. Okay, so now you're back. Hopefully, you've already examined that. So let's see here. There are some key elements here. Here we have an even exponent, an odd exponent. So that's even. This is odd. This one is even. And this one here is odd. So notice what's the same about the evens. The evens match up, right? Up, up, or down, down. And the odds alternate. This one is down, up. This one's up, down. Now, what's the difference between these two? What's the difference between these two? Why is this one up, up, and this one down, down? Why is this one down, up, and why is this one up, down? Well, the key here has to do with the coefficient. Notice the coefficient on this one is negative, down, down. The coefficient on this one is positive, up, up. So first we consider that we have an even exponent, so they match. It's both up or both down. And then we look at the coefficient. So more specifically, this is a positive 4, and more specifically, this is a negative 1. So how do we analyze that? Remember, so here, this one matches, right? And this one alternates. So if n is even, it's going to match. It's going to be up, up, or down, down. But when a is greater than 0, that's positive, we have up, up. And when a is less than 0, that's negative, we have down, down. Okay, so how does that compare over here? So like we said, odd alternates, and notice this exponent here is positive, excuse me, the exponent is 3, the coefficient is positive 1, and the coefficient here is negative 1. So notice what the positive 1 does. The positive starts low, ends high. And the negative coefficient starts high and ends low. So let's break that down. When we have a positive exponent, it goes down, up. Excuse me, a positive coefficient. And this one here is up, down. Up, down. So I like to consider this in this manner here. Notice that the negative here kind of tells me that we're going to have down, down over here. We'll have downs for the on the right, down on the right, down on the right. And alternatively, whenever you have a positive coefficient, it on the right is up. On the right is up. So hopefully that gives you some insight as you practice the next ones here. All right, what about the turning point here? So let's look at this one. The turning point. Now remember, a turning point says the behavior changes. Up, 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 flat up. So notice it hasn't turned, it just paused going up. So this one has no turning points. 0 or none or the nil situation here. All right, so let's look at the turning point down here. This one, as I'm going left to right, up, 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 boom. So at this moment right there is when life changes and it begins to go down. So at that point in time, 0, 4 is its one and only turning point. And this one here clearly has 2 turning points. Going down, 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 hits this trough, this relative minimum comes back up and down. So those 2 are my turning points here. So -1, -2, and 1, 2. All right, the last thing we want to consider is increasing versus decreasing function. And this gets a little bit more complicated, so I do apologize for these decimals and numbers here. So it's probably easiest to start with this one right here, increasing. We want to know from left to right, when is the function essentially going up or not going down, right? So here it's going up, 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 flat lines, up, 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 up. So its behavior still, it's always increasing. So we actually simply say always increasing. And even though it pauses momentarily right here, the trend, it also means it's not going, it's never decreasing. Okay, so what about this one here? When is this function increasing? When is this one decreasing? Well, notice right here, we have an increase, then at the turning point it changes, and now we have a decrease. So, how do we write that? Well, we say that this function is increasing when x is less than 0. So here's the 0 right there, and it's increasing from on this side, and over here it's decreasing on this side. Excuse me. So when x is greater than 0. So there we go. That is the increasing and the decreasing. This gets a little more complicated, the third one. So when does it increase / or decrease? Well, it's decreasing. The function decreases here, but also decreases here. So when is it decreasing? It's decreasing when x is less than -1. So it's decreasing all over in this way, but it's also decreasing here when x is greater than 1. So what happens in between? Well, here is where it's increasing, and it increases when x is between two numbers. And which two numbers are those? Well, when x is between 1 and -1, that's when it's increasing. So notice I'm differentiating here with color, but also with labels. Increasing in this region, decreasing in this region. So the last one here is a little bit more ugly to do just because we have so many decimals, etc. So I'll try to keep organized here. So when are we increasing and when are we decreasing? So let's look here. Increases from here to here. So that corresponds to x being negative 2.236, and x is up to 0. So that's when it increases. And it also increases this way here. So when x is greater than 2.236. All right, what about decreasing? Well, it decreases here when x is less than that value. So x is less than -2.236. And it also decreases in this region right here. So when x is between 0 and the 2.236. And there we go. So those are all the components that we're considering here. What are my turning points? And notice the turning points in increase and decreasing are exactly matched up, right? This has 0 turning points, so it's always going up, or if it were going this way, it would be always going down or always decreasing. This one here, the turning point, it is increasing in this region, and at the turning point, it's decreasing. And there we go. Now your job is to practice this right here. Please pause. Well, no, I'll just post it. I'll just post this on Google Classroom here. So post the results and you can check there. Enjoy.